Welcome back to Deep Learning for Babies with Professor Waldo. In this episode, we're diving deeper into the magic behind deep learning, specifically the math that powers neural networks. Grab your notebooks because we're about to decode the formulas that make AI so intelligent. Let's get started. Before we get started, let's recap. Deep learning models learn through a cycle of trials, adjustments, and error corrections. For example, in this illustration, the model is learning to recognize Homer Simpson. The input itself is an image of Homer, and the label is Homer Simpson. The model starts with initial guesses, checks how far off it is, and adjusts certain parameters to minimize the prediction error. This process repeats until the model improves and gets closer to the desired outcome. Now let's dive a bit deeper into how these neural network models work. Many models in the real world can be described by the line equation. Let us take a look at the equation of a line. Any line can be described by y equals mx plus b. The value of y can be referred to as the predicted output equals the input x multiplied by a weight m and then added to a bias b. This is the fundamental principle on the basis of which artificial neurons work. An input x is multiplied with a weight w and added to a bias b. The output y is then passed through an activation function to give the final output, which we will discuss subsequently. Initially, the neuron's output or the prediction will be way off. By systematically adjusting the parameters weight and bias and repeating the trial and error, the neuron eventually produces the right output with no difference or error between the predicted output and the expected output. That's all for today, folks. In the next lesson, we'll dive into some specific examples where we can apply this line equation and see how it powers real-world deep learning applications. Stay curious, and I'll see you next time.